everyone. Today I am going to explain an important statistical concept that plays a major role in machine learning, that is Bayes' theorem. So Bayes' theorem helps us update our beliefs based on new evidence. It is widely used in classification problems, spam detection, medical diagnosis and many real-world applications. So let us begin by understanding what Bayes' theorem actually means. So this is the answer for the previous question time. So you have to refer it. So in this slide contains some recap questions related to hypothesis space and evolutionary search is there. So you have to refer it and then get the answer. So now we have to start. What is a Bayes' theorem? So Bayes' theorem is a mathematical formula that calculates the probability of an event based on prior knowledge and new evidence. So in simple words, it will be described to Bayes' theorem means it helps us update our beliefs when we get new information. So the formula is P of A by B equal to P of B by A into P of A by P of B. So now explain. First, P of A by B is the probability of event A happening given that B has occurred. So here A it will be happen and then B is occurred. Okay, then P of that means probability of P by A is the probability of observing B if it's true. Then P of A is the prior probability of A and then P of B is the probability of evidence B. So in this formula allows us to move from prior belief to updated belief. So Bayes' theorem in machine learning. So in machine learning, Bayes' theorem is extremely important because it helps us make predictions using probability. It is mainly used in classification problems. For example, determining whether an email is spam or not. Okay, so when a new email arrives, in the sense we calculate the probability that it belongs to the spam clause using Bayes formula. So whichever class has higher posterior probability becomes the predictions. Okay. So for in classification problems, Bayes' theorem helps calculates the probability that a data point belongs to a particular class. For example, if an email contains the word offer, we calculate what is the probability that this email is spam using Bayes' formula. So posterior equal to by evidence. Okay, so posterior equal to, again I will repeat the formula, posterior equal to likelihood into prior divided by evidence. So the class with the highest posterior probability is selected. Okay, so the next one is Bayesian networks. So the Bayesian networks are graphical models that represent probabilistic relationships between variables. They use Bayes' theorem to compute conditional probabilities. So for example, disease implies symptom relationship can be modeled using a Bayesian network. So if we know the symptoms, we can calculate the probability of disease. So for example, if we get a sneeze or else a cough, in the sense so in that symptoms represents okay the cold or fever will be coming to us, so like that is there, no? So that is called a Bayesian networks. Okay, the next one is Bayesian inference. So Bayesian inference is a method of updating probability as more data becomes available. It starts with a prior belief, then it observes new data, then it calculates posterior probability. So posterior probability becomes the new belief. Okay. So the next one is applications of Bayes theorem in machine learning. So the Bayes theorem is used in spam detection, medical diagnosis, image recognition, and natural language processing. So now explain in each one. So the first one is spam detection. So it classifies emails as a spam or not spam. So for that purpose we have to use the Bayes theorem in machine learning. And the second one is medical diagnosis. So it calculates the probability of disease based on symptoms. So we already discussed that one, no? So we have to get symptoms like in a sugar or pressure or whatever it is, in giddiness is there, means like pressure. So for what are all the symptoms we have to get it. So it related on the symptoms only we have to get diseases, no? So for that it's a medical diagnosis. And then organization. So for determines probability that image contains a certain object. And then NLP, natural language processing, it predicts the probability of words in language models. Okay. So the next one is key concepts behind the Bayes theorem. Okay. So the first one, prior probability. So the prior probability represents what we believe before seeing new data. Okay, so prior probability, that means it's priorly, beforely we have to imagine the, so this is the outcome, we have to get it like that, it is not. So that is called a prior probability. So example, if 30% of emails are spam, then prior probability of spam is 0.3. It acts as our starting point. Then is likelihood. Okay, so likelihood measure how likely the evidence is assuming the event is true. So for example, if the word offer appears in 80% of spam emails, then likelihood is 0.8. So likelihood adjust our belief based on new evidence. So it will be adjust the likelihood. So it's based on the new evidence. It will be evidence the much more it's effective, in the sense it will be the likelihood adjustments will be, the likelihood measures will be changed it. Okay, so the next one is posterior probability. So the posterior probability is the updated probability after considering evidence. So what is the probability that email is spam given that it contains the word offer? So posterior equal to likelihood into prior divided by evidence. So this is the final output of Bayes theorem. So the first one we have to get it from the prior probability, the second one is likelihood, the third one is posterior probability. Fourth one is evidence. Okay, so evidence is the probability of observing the data under all possible classes. It acts as a normalizing factor to ensure probabilities remain valid. So for here in that table clearly explain how Bayes components are working. So for prior probability, in the sense it's a baseline probability before new data. So it's the example 30% of emails are spam. And then likelihood, so probability of observing data given the event. So for here it's example of 80% of spam emails contain offer. And then posterior probability, it's updated probability after observing data. So probability an email is a spam of it if it contains offer. Okay, and then evidence, overall probability of observing the data, that means 10% of all emails contain offer. Okay, so we have to conclude the session. So the conclude Bayes theorem is a more powerful statistical tool that helps update probabilities using new evidence. So it plays a central role in machine learning, especially in classification and decision making systems. Okay, so as machine learning continues to grow, Bayesian reasoning remains a fundamental concept for intelligent systems. So for the Bayes theorem will undoubtedly remain an important tool for data scientists and machine learning experts alike as machine learning develops and becomes more significant across many domains. Next session is question time. So here is the questions. You have to refer these slides and then give the answer to them, and then note it down your answer. In the next class we have to you have to get your answers. Okay, I'll I understood. Okay, you have to understood these concepts, in the sense you just in a fraction of the second you have to answer these questions. Okay, if you have any doubts, ask the questions in the next class. Okay.